In the entire periodic table, there is one element that pushes nature to its limits, a substance so reactive that it attacks glass, ignites metal, and rips electrons away with unmatched force. This is fluorine, the most aggressive element known to science. Fluorine is astonishingly rare in the universe. Its atoms are so unstable during stellar fusion that most stars destroy it as soon as they create it. To survive, fluorine must be forged in extraordinary events: red giant stars, supernova shockwaves, or even the violent winds of Wolf-Rayet stars. That makes fluorine one of the least abundant, naturally stable elements in the cosmos. Yet on Earth, it plays a role far larger than its abundance. Fluorine sits at the top of the halogens, and it rules them. Its electronegativity, 3.98 on the Pauling scale, is the highest of any element. No atom pulls electrons harder. The result? Fluorine reacts with almost everything: hydrogen, silicon, iron, copper, organic molecules, even noble gases like xenon, once thought completely inert. This is a gas so reactive that pure fluorine must be stored in containers made of nickel, because the metal instantly forms a passivating layer that stops further attack. But the initial attack is guaranteed. At room temperature, fluorine gas can ignite powdered metals, including steel. It can form explosive compounds with hydrogen. It reacts with water violently, releasing hydrofluoric acid and oxygen. And its radius is so small that fluorine atoms slip into chemical bonds that no other element can approach, creating some of the strongest bonds in chemistry, like the carbon-fluorine bond. This bond powers everything from Teflon to advanced pharmaceuticals to the thermal shielding used on spacecraft. Biologically, fluorine is a double-edged sword. In nature, it rarely appears as an element, only as fluoride ions or bound in minerals. In tiny, controlled amounts, fluoride strengthens teeth and bones by forming fluorapatite, which resists acid better than natural enamel. But in larger doses, fluorine compounds can be devastating, interfering with calcium metabolism, disrupting enzymes, and damaging cell membranes. Hydrofluoric acid is among the most dangerous acids, able to penetrate skin without pain, dissolving deep into tissues and binding to calcium in the blood. Why does this element act with such ferocity? Why is it born only in the universe's most delicate stellar environments? Why do its atoms bend the rules of reactivity more than any other? Fluorine is the element that rewrites chemical intuition, a ghostly gas with cosmic origins and earthly power. The universe's most aggressive atom, silent, pale, and unstoppable. The most reactive element in existence.